Hello and welcome to another video of this object-oriented programming series. In this hands-on video about chaining constructors, I'll refactor the implementation in the constructors from the last version, 1.4, make them more efficient, and the purpose of which will be to remove the redundant code that we've come across. So this is where we left off during the hands-on video of the previous version. We've been enabling the client to create objects using 4 different constructors. First of all, by passing 4 arguments, then using a default constructor, using 2 arguments, and finally the copy constructor. We made this possible for the client because we implemented in the rectangle class those 4 constructors. So the first constructor we discussed was this 4 parameters constructor, to which the client can pass arguments for x, y, height and width, after which the constructor calls the setters. The second one was discussed was the default constructor, so no parameters defined, and we pass some default values to the height and the width. Then the copy constructor, to which the client can pass a reference to an already existing rectangle object. Using that object, we use the properties of that object to pass to the setters, and then we created a 2 parameters constructor to which the client can pass a height and a width, for which we call the appropriate setters. Just to note about the order in which I implement a constructor, I implement constructor in an ascending number of parameters. So the default constructor doesn't have any parameters. Then we have a constructor with 1 parameter, then a constructor with 2 parameters, and then finally a constructor with 4 parameters. So you know why I implemented this way. Okay. Now, what is a problem we are currently facing in the constructor? If you compare the implementations, you see that quite a lot of setters are invoked. Here we have 4 setters, 2 setters, 4, and then another 2 here. And the first problem is that, well, a lot of setters are invoked, the same setters in the different constructors. A second, more important problem is that it is too easy not to call a setter, to forget to call a setter. For example, in this copy constructor, suppose that we forget to call the set height for some reason and the set width. There will be no compiler error and our object will be in an invalid state, because our new object will get default values of 0 for the width and the height. So forgetting to call a property will result in an uninitialized object, and so the object to be possibly in an invalid state depending on the property. Definitely so if we forget to invoke the setters for height and width. And then the third problem is that, well, suppose that in a later stage a new property would be added to the rectangle class, say a color property. And this is definitely something we would like to do when we move from a console application to a desktop or a mobile app application, where we want to draw our rectangle in a specific color. So for that we add a new property, color. We add its corresponding getter and setter, and then what we need to do in order for the color to be properly initialized is that the set color must be invoked from each individual constructor. And that is quite error prone, because we might forget to call a setter. What is a better way to prevent properties from being uninitialized? Chaining constructors. And before demonstrating how chaining constructors work, I'll add the necessary packages for this new version. So on lib, right click, new package, demo 05 chaining constructors. Do the same in the app. And copy the classes from the previous version. Rectangle, copy, Ctrl C, paste, Ctrl V. And for the client app, drawing app, Ctrl C, and paste it in the package 05. Now make sure that I'm importing the correct version, so not demo 04, but 05. Make sure that everything compiles smoothly, so run the code. And I've got the same output as before. So let's implement chaining constructors. In rectangle class, let me scroll down to the constructor with the most parameters. In our case, 4 parameters. Because the idea is the following. Have the constructor with most parameters invoke all the necessary setters. So basically we don't change anything in this constructor. And then second, have the other constructors invoke the constructor with most parameters by passing the necessary arguments using the this invocation. Let me demonstrate that with the default constructor first. I'm going to comment this first and then invoke the constructor with most arguments, being this one. How do we do that? Using the this invocation. So we use a keyword this, more on that in a second, and then we pass 4 arguments. And then the purpose is to call this constructor. So we need to pass 4 arguments. What are the values? Well, what is the default value for x, y, height and width when I am in the default constructor? Well, we only call the setters for height and width with a specific value of 10. So they both get the value of 10. What about x and y? Since the setters are not invoked explicitly, they get the default value at runtime, which is 0. So for the x argument, we pass a value of 0 for y as well. And then for the height and the width, we pass the value of 10. And let me just first pass 10 directly. Semicolon, reformat. What will happen now at runtime? Well, whenever the client creates an object using the default constructor, so by passing no arguments, the runtime will invoke the default constructor as before, and then using this invocation, we'll call the constructor in the same class by passing 4 arguments, and that constructor must exist. In our case, the constructor does exist, and the this invocation will then result in the invocation of this constructor, which will receive the values of 0 for x, 0 for y, 10 for height and 10 for width, after which the 4 setters will be invoked. Once this is done, control resumes in the default constructor, this invocation is done, and we return back to the client. So the client will not notice anything different from happening. The output will be exactly the same. It's just at the implementation side that we decide to implement it in a different way because we want to remove the redundant code from the previous version. Okay. Let me do this for the copy constructor. Again, we're not going to call the setters explicitly anymore. We replace this by invoking the constructor and then passing the arguments that we previously passed to the setters, rect x, rect y, rect height, and rect width. Pass those values while invocating the constructor with most parameters. So rect.x, rect.y, rect.height, and rect.width. And then the same happens. So the client creates an object using the copy constructor. So we jump to the copy constructor. We're not going to call the setters directly anymore, but we are relying on the other constructor that we invoke explicitly by passing the 4 arguments. So we arrive at this constructor, which will call the different setters, after which we return back to the copy constructor and we return back to the client. Again, the output will be exactly the same. Well, finally, let me do this for the 2 parameters constructor. So I comment the setters, and then using the this invocation, what did we pass to the setters in the previous version? The values of the 2 parameters, height and width. No setter is called for x and y, so we just use the default value of 0 and then the values of the parameters, height and width. And then the same output will be created. So let me run this. And we get exactly the same outputs. So this for the implementation of chaining constructors. Time to tackle a problem we are faced with now in the current version. Chaining constructor is useful because it becomes less obvious to forget to initialize a property. This default constructor, for example, if the idea is to call a constructor with most parameters, in our case 4, well then we must pass 4 arguments. We cannot just pass 3 arguments or 5 arguments. It has to be 4. Now, I admit we could have passed 2 arguments. That will result in calling a constructor with 2 parameters, which will then in turn call the constructor with 4 parameters. I prefer to always call the same constructor, the one with most parameters. So chaining constructor is useful, but we are faced with a new problem now. Suppose that I want to use these constants. There's a good reason to use constants, which I will emphasize in later videos. Suppose I want to use this min height, min width, and even before continuing I already get a compiler error. But the idea is that actually I would replace the value of 10 by the min height and the min width. But I can't do this. Let's have a look at the compiler error. Call to this must be the first statement in the constructor body. What does it mean? Well, that no other statement may occur before the this invocation. So let me undo the code. So back to 10 and 10. Even then, it's not because I'm using these constants, it is because before this statement there are some other statements in the constructor, and this is not allowed. So I'll put it back in comments. So the invocation of the other constructor must be the first statement in the constructor body. And this is to ensure that any properties of the class are in a proper state prior to executing any other statements. So first we make sure that properties are initialized. If not in this constructor, then in another constructor before doing anything else. Even defining a variable is now defined. And this is unfortunate because in this version I'm chaining constructors, but then I can't use any constants. And I want to use constant. So how to deal with it? How to combine both? Well, that's what I'll demonstrate in the next version, where I'll define class member variables and use those in the constructors. Thank you for watching and see you in the next version. If you like this video or any other video of this series, thanks for liking it or subscribing to my channel. Bye bye.